My name is Alex Taylor. We're talking about self-driving cars this morning, and you seem that you can't open a newspaper without reading something about them these days. Every day, Volvo, GM, Ford. Our guest experts are two men who could easily be described as rocket scientists. Dr. Ken Washington from Ford Motor Company, who came to Ford from Lockheed Martin, and Dr. Gill Pratt, who formerly was working at DARPA. So we're going to do about 10 minutes from each of these gentlemen, 10-minute Q&A, and then we'll open it up for questions from the floor. I have to remind you to cast your vote when we see what the question comes up. Do you plan to buy a car that drives itself when it becomes available? Yes, no, or uncertain. And we'll take another vote at the end of the session to see how many minds we've convinced or scared away. Ken, you want to start it off?
Sure. Well, good morning. It's a pleasure to be here with you. I'm going to give you a quick overview of what we're doing at Ford and how we think about the world and the challenges and the opportunities that are here in terms of how technology can help us move and make people's lives better and save lives. So let me start by setting the context. Mankind has always had, for centuries, the desire and ability to move from one place to another, roughly on the order of an hour to an hour and a half a day. That hasn't changed. What's changed has been how technology has enabled that movement to be different, more pleasurable, and allow you to go further. The biggest disruption over 100 years ago was driven by the founder of Ford, where vehicles were enabled to be bought by the common man or the common woman. Before the moving assembly line, it was reserved for the rich. They were custom-made coaches that were out of the reach for the common man. This put the world on wheels and allowed people to go further, to move from one place much further to another place at a cost that was affordable. This was a huge disruption in the future of mobility that happened 100 years ago. And we're about to see another disruption. We're about to see another disruption, and that disruption is going to allow us to continue to think about mobility as being freedom. If you think about it, the ability to move is freedom. And we want to be able to have that freedom, whether you can drive or not, and whether you live in a city that's congested, or whether you have a driver's license or not. And you want that to be safe. It shouldn't put you in harm's way. And that's what the promise of autonomy is. The promise of autonomy is going to help us deal with some of the challenges that we face today with population growth and congestion, cities turning into megacities. These are cities and urban environments with 10 million people or more. And there are opportunities in there because we're talking about cities becoming smart, being equipped with sensors so cars can talk to them. Other challenges that we face have to do with us. Changing demographics. My dad is 84 years old, and he really shouldn't be driving anymore, but he really wants to because mobility is freedom. What if I could put him in a car and have the peace of mind to know that he's going to be safe? And the rising power of women and challenges in big, densely populated areas like the megacities in China. And of course, we have to take care of our planet. Climate change, limited natural resources, and changes in the regulation environment are giving us pause about continuing to provide this mobility freedom that we've been doing for the last 50 plus years. It's making us rethink mobility. And the good news is there's a lot of fresh thinking out there. We now have a generation of people who don't know a world that doesn't exist without the internet. We call them digital natives. We've got rich social media. We're all walking around with supercomputers in our pocket, smartphones. And we're thinking about ownership differently when it comes to mobility. All of these things are coming together to create new challenges and new opportunities when it comes to mobility and freedom. And these are colliding with this tsunami of big technology changes and disruptions, having to do with sensors that are now cheap enough to actually integrate into mass-produced vehicles. We understand the human condition better, biotechnology, cloud computing, It's basically enabling us to put fast computers in the cars, Internet of Things, everything's connected to everything else, and of course, the big disruption that we're going to spend a lot of time talking about today, which is robotics and machine learning, is giving us the ability to make our cars smart like almost like we are. This is what we have coined Ford Smart Mobility, the promise of stitching together the capabilities to be connected to everything, everywhere, and enabling new ways to move with new mobility solutions, making them autonomous, enabling us to harness the power of big data to make people's lives better and have better experiences. This is the promise of it giving us that next wave of mobility freedom that happened more than 100 years ago, but this time it's going to enable us to move ourselves autonomously and safely. I'm really excited about this future. So let me talk a little bit about how we're going to do that. The first thing to realize is that this is not a local United States opportunity. This is a global opportunity, which is why we began looking at and experimenting all over the world with new ways to move. And it taught us that how you approach this problem should be based on specific regions, and it's a great place to start in terms of understanding where you're going to focus on making people's lives better within a specific region. So I'm going to talk about how we're enabling autonomy for what we think is going to be a game changer in terms of enabling mobility, autonomous mobility in the year 2021 with a vehicle that can be fully autonomous without a driver that will deliver you to where you want to go without concern about hitting something or having the ability to jump in the front seat and grab control. So this is really taking you out of the loop so that you can be transported to where you want to go. But we kind of have some of that today. And so it's important to kind of understand that when I'm talking about full autonomy, I'm not talking about the kind of autonomous features that you can have and you benefit from today in the vehicles we drive and manufacture today, which have these driver assist technologies on them that can sense the environment and help you. All of these helpers that are on vehicles today, like adaptive cruise control and blind spot monitoring and lane centering and automatic braking assistance, all of these things are helping us be better and safer drivers. But we still have to be drivers. You have to drive the vehicle. You are in control. What I'm talking about is the promise of full autonomy. Tomorrow, we're going to have the ability to be fully autonomous. And that's going to be possible because of the advent and the maturity of advanced sensors and computing, all the things I've been talking about. The Society of Automotive Engineers has defined levels of autonomy. And at this level of full autonomy, I'm talking about what's called level 4. So you'll hear that term tossed around, and what it basically means is a vehicle that does not require you to have control of the steering, braking, or acceleration. This is my geekiest chart, and I'm not going to explain it, but I wanted you to see it because I don't want anyone in this room to walk out of this session without appreciating that when car companies talk about putting a fully autonomous vehicle on the road, we're talking about developing some very sophisticated software and marrying it with some very sophisticated engineering that allows our vehicles to be integrated with that software. And it requires us to understand the rules of the road, to predict the motion of objects that we see, to understand what those objects might do, to understand the intent. It's a very hard problem, but we're prepared to address that hard problem because we have been doing this for more than 10 years, starting more than 10 years ago with participating in the first DARPA challenge. So now we've taken all that and we've put it into a fleet of test vehicles that we have on the road today, testing a fully autonomous capability. We have 10 vehicles on the road today. By the end of this year, we'll have 30. And they're being tested in controlled environments. These are test tracks that we have and also that our partners have. This particular picture is from the University of Michigan's M-City, which is a simulated city with realistic intersections and buildings. Next year, we're going to triple that fleet again. So we're going to have up to 100 vehicles on the road testing full autonomy. So this is not science fiction. We have this today, and it's really working. It's not always sunny when we drive. Sometimes you drive in inclement weather, and so we're testing these vehicles in inclement weather conditions, including on the snow. And to our knowledge, this is an accomplishment that is pretty important, and we haven't seen others be able to do this. So we're pretty proud of our team's ability. So earlier this week, we made a pretty bold announcement, and so I'll repeat that today, and then I'll end here, which is all of this is coming together quickly enough because of the speed of technology that's happening that we believe and we have the intent to mass produce a fully capable level 4 autonomous vehicle and to put it in a ride service by 2021. And we're doing that with the help of a number of technology partners, including some pretty capable sensor companies that know how to do machine learning, and the world's leader in doing advanced sensing using lasers. It's a company called Velodyne, and a small startup that's helping us understand how humans see so that we can embed that technology into our vehicles to help our vehicles see and make good decisions as it takes you from one point to another. So with that, I'm going to end and say thank you again for having me, and I look forward to the dialogue.
Yeah, okay. So the first thing that I want to say is Toyota and Ford are certainly competitors, but we actually have a long history together, and actually both Ken and I are relatively new to each of our companies, and the same DARPA office that I did the robotics challenge out of was one that Ken in fact worked with quite a bit before in his work at Lockheed. So not only do we personally share a lot of history, but actually Toyota and Ford do quite a bunch as well, and you can look that up online and see lots of neat things. So what's neat about this field is that it's an opportunity for both competition and cooperation. And I would love to chat about that in the Q&A or any other time too. I had begun the work that I did with the DARPA Robotics Challenge. Ken did a very eloquent thing talking about different kinds of smarts that are in cars. There's the kind where you're driving and the car avoids letting you have an accident. And then there's the kind where the car takes over for you and drives instead of you. It turns out that while I was at DARPA, we studied these 3 different kinds of autonomy, and 2 of them relate to the particular way that we're approaching this problem. So the first one I'll show you at the top is called series autonomy. And it has basically the commander, the subordinate, and the environment in series with each other. They're in a line, okay? And the way to think about this is this parent on the right-hand side coaching a child that's playing golf and telling the child, hit the ball over there. So we have the parent as the commander, the child as the subordinate, and the environment is the golf club and the golf course. And then, of course, we see what happens, and then they do it again. I want you to compare that with the one on the bottom, parallel autonomy. That's where the parent and the child are holding the golf club together, and what they're saying is, I'll help you swing. And so we have a human and we have an autonomy system working together, interacting with the environment, and then you can see that they're basically in parallel instead of in series as before. There's an intermediate form in the middle that I won't talk about very much, which is the interleaved mode. Typically, you see this in planes that have both a pilot and a co-pilot, and each one hands control to the other going back and forth. So let me show you, since I think I know the slide deck here, an experiment from DARPA that relates to the last talk that Arthi Prabhakar just gave on revolutionizing prosthetics, which was one of the projects at DARPA. Off the screen here is Jan, the person she mentioned in her talk, and Jan has a brain implant. And that brain implant is controlling the robotic arm that you see here. On the left-hand side, that robotic arm is moving the white block, and she's attempting to move that white block to the white square that's on the upper right-hand side. That's the goal. On the left side, she's trying to do it completely on her own, just from the implant that's monitoring the motor part of her brain. On the right-hand side, there's this neat thing going on where there's an AI system working in parallel, just like that parent with the child with the golf club. And what the AI system is doing is noticing what her intent is. When it sees the arm over on the left-hand side trying to pick up the block, it says, oh, it looks like you're trying to pick up the block. Let me help you just a little bit. Let me nudge you just a little bit to close that arm, that hand just in the right place to pick it up. When she's moving over to that right-hand square on the right, it's like, oh, I see you're trying to place it down there. Let me nudge you just a little bit. And so here's what's so cool about it. On the left-hand side, it never works. On the right-hand side, it works every time. We randomly turned the autonomy on and off here. This is parallel autonomy, the helper that helped her. And guess what? She couldn't tell when it was on and when it was off. She thought that some of the time when it was on, she was doing it alone. And she didn't realize that she completely needed the autonomy to help her do it. So she maintained her sense of agency throughout the whole thing. So that was a really neat result. And that led me to then go work at TRI. And I'll tell you what it led to. Let me see if I can remember these slides here. Okay, here's the two approaches. And this relates very much to what Ken just said. Series autonomy. The parent tells the child, hit the golf ball over there. We call that the chauffeur mode. Turns out Google uses the same word for it. Now, this says, I tell the autonomy, take me home. That's the full autonomy that Ken was talking about before. Who's liable for an accident when that occurs? Is it the passenger that told the chauffeur, take me home? Or is it the chauffeur? It's the chauffeur. And if the chauffeur is now the manufacturer who wrote the software and the hardware, of course, the manufacturer is liable. How good does it need to be? The chauffeur's got to be perfect, or at least not get into an accident for all of driving. Has to do it 100% of the time. How soon can we deploy this thing? Well, it's kind of an all or nothing thing. Either the chauffeur can take you the whole way or they can't. And in the meantime, people are still having accidents. How about the skills that the driver has? Those skills are ignored until, because the chauffeur has to do all the work. And then this particular thing, which the president of Toyota had impressed on me, is that even though it's wonderful to have a car to take you where you want to go in chauffeur mode when you're the passenger, it's also fun to drive. And so if you have the chauffeur, the car essentially becomes a train getting you from point A to point B. Now, the automatic emergency braking and lane keeping and other assist systems we have now are very primitive examples of parallel autonomy, which is like what we call the guardian angel or the guardian system that's on the right-hand side. I want you to contrast this to the left-hand side. In a guardian system, we are aiming to create a car that when you drive it, will never be capable of causing an accident. I want you to imagine a car that you're in. You can close your eyes, step on the gas, turn the wheel, keep your eyes closed, nothing bad will happen. That's quite a car, huh? Now, we're not anywhere near there yet, but it turns out the technology is very much the same as the one for the chauffeur, except it doesn't engage all the time. It only engages when it thinks that you're about to have an accident or you're getting into a situation that's going to be bad. In this case, the driver keeps the liability. The competence is basically don't make things worse. How often does it have to work? Less than 1% of the time. We, in fact, think for most drivers, less than 1/100% of the time. We can begin to save lives as soon as possible. Ford is certainly doing this now, too. But our intent is actually to take this much further. And the driver's skills are utilized as much as possible instead of being ignored. And the car actually becomes more fun to drive. If you really love to kind of push your car to the limit, you now have a safety net that you didn't have before because the AI inside the car won't let you crash. That's a pretty fun car to drive. So that's our thought. Here's a chart that kind of sums up the whole thing. Many manufacturers are trying to climb directly up the left-hand side. I believe Ford is actually doing both, so I don't think that we're that different. But for Toyota, we're intending to push much, much further to the right while we still work on going up. Up in this case is the chauffeur mode, the series autonomy. You tell the chauffeur, take me home. It drives the car for you. The stuff on the right is parallel guardian angel sort of things where the car does not allow you to have a crash even though you're driving the car. And so basically our main theme is to try to push that as hard as we can. And so with that, I'll show you one last slide. This was also from the other presentation. This is Jan again doing parallel autonomy, but not a very boring task. Here she's trying to do something very practical. She's trying to open the door. And this is the first time it was ever done. This was 2 years ago at DARPA. And you can see her head there in the lower right. You can see the electrode assembly coming out of her skull. And thanks to the assist that's operating in parallel with her brain commands, she's able to do this task, which no one in a brain-machine interface had ever been able to do before. And you'll see her head kind of shake because she manages to do it, and she's incredibly thrilled that she manages to make that work. So this particular work, DARPA just funds things, so that was done with a lot of help from CMU and the University of Pittsburgh. But I hope that this somewhat jumbled talk here gave you an idea that, in fact, there are 2 modes, and for convenience and access and many of the other great things that Ken talked about, we're all working on the Chauffer mode, but in the meantime, we also have this Guardian mode that we think can tremendously enhance safety as we work our way to get there. Thank you.
Ken, a lot of times the barriers to autonomous driving seem to be as much legal and ethical and logistical as they do technological. Is Ford putting the same kind of emphasis on those areas as it is on the technology behind these things?
We understand the importance of dealing with the non-technical challenges. There are many. There are challenges associated with, insurance, with policies within cities, and we expect those policies to be different depending on the region. It's pretty clear to us that addressing these problems has to be done as an industry, and I think Gill teed that up very nicely, which is there's competition within the automotive industry to push the competitive technology faster than the competition, but there's plenty of rich opportunity for collaboration, and this is one, where the industry needs to solve these problems. We need to work together as an industry to work with policymakers to inform them what's possible, what would help, and what would not help. For example, it would really help if there was a federal set of standards for testing and evaluating and certifying self-driving, fully autonomous and semi-autonomous vehicles, because it would be an absolute mess if you had to deal with different policies as you went from one state to another to another. So we're working together with several automotive competitors and with several technology companies in various consortia. The Self-Driving Coalition for Safer Streets, we're a proud founding member of that, along with Google and Uber, and I believe, I'll get it wrong if I guess the other OEMs that are in it, but there's several other OEMs that are members. And these are the kinds of collaborations that we need to advance to solve these policy, ethical, insurance, and other non-technical challenges.
Gil, 20 years ago, Toyota led an effort to popularize hybrid cars, in fact, pioneered the hybrid drivetrain.
Yep.
20 years later, you could say that was a huge success. It was done inside the company, and everything worked out fine. Yep. Now you're trying to do driverless cars from outside, essentially, the company in the Research Institute. How are you integrating that with the product plans of the corporation?
So that's a very interesting question. So the chairman of the board of Toyota right now is Mr. Uchiyamada, who actually was the chief engineer of the Prius when it first came out. So in fact, the authorization for the Toyota Research Institute came from him. So we're tied to that different era of when the company decided to take this very big gamble at the time on the hybrid drivetrain. And the particular one that Toyota chose, amazingly, was the most complicated possible way to do it. It has not one motor generator, but 2, and a complex differential that's added to the car. So not only do you have the battery, 2 motor generators, the differential, all of these things, and the engine, and all the other, it just sort of, who would ever do it this way? But they did very careful thinking, which Toyota is very well known for, and decided, despite all of that initial feeling, this was actually the right thing to do. I think we're seeing that same kind of boldness now for autonomous cars. And it's not actually just us. Ford is doing it too. Lots of the other OEMs are doing it, and IT companies as well. Google, the rumor with Apple, I don't know. Others are thinking of doing the same thing. So I think there's a lot of boldness there. Whether it's internal or external, we have around 20% of our staff from Toyota in Japan that's working directly with us, and they come from the same development divisions that are doing this type of work. So that's definitely part of it.
If I could,
Yes.
Alex, if I could add sort of a Ford dimension to this, and I think this applies to Toyota too. I think it's important to remember that when you're talking about developing a fully autonomous or even a semi-autonomous vehicle with driver assist technologies, that there's still a vehicle involved. And there's a lot of myth about, if all you have to do is develop some complicated software to do the driving part and then bolt that onto an existing vehicle. And I'd like to debunk that because I can tell you from experience in working with the Ford team that the engineering and the sophistication of doing the platform, the vehicle platform, to interface with the software, to have the kind of redundancy that you need. Because if you have a failure in the self-steering on a car that's running in chauffeur mode, to use Gill's words, you can't override that with a person, because muscle is the backup, right? Well, you're not going to have the muscle, so you need to have a redundant set of actuators to flip over to the B side, if you will. So there's a lot of sophistication that happens that has to do with the core vehicle engineering. And by doing this within an automotive company, it gives us the advantage of being able to tap into that engineering know-how, to marry it with the new technologies of sensors and automation and robotics and machine learning. And we think it'd be very difficult for a technology company to do that without engaging an automotive company, which is why this is, we think we're extremely well positioned to bring this to a reality within the next 4 to 5 years.
And let me add even more to that. So that's exactly right. And I want you to all to think about how hard this problem actually is. And the night after I signed my contract to go work for Toyota, I couldn't sleep. And the reason I couldn't sleep is that they had told me some facts, and then my mind was kind of running. The first fact was Toyota makes on the order of 10 million cars per year. Okay? Every year it's a little different, but order of 10 million. Not 1 million, not 100 million, 10 million. Okay, that's a lot of cars. How long does a car last? Order of 10 years. So 10 million per year, 10 years is their lifetime. That means there's around 100 million Toyotas in service around the world at any given point in time. How far do they travel each year? Well, around 10,000 miles. It's not 1,000, it's not 100,000, around 10,000 miles. Okay, multiply all those things, and what do you get? You get 1 trillion miles per year of all Toyotas around the world travel. Okay, 1 trillion miles. Those of you that are nerds like us, 10 to the 12th power. Okay? Now, presently, the company that everyone thinks is out in front, although we all debate by how much, is Google. How far have they tested? 1.8 million miles. 1 million is 10 to the 6th power. What's the difference between 10 to the 6th and 10 to the 12th? Factor of 1 million. Okay? So now, how good do our cars need to be? How many accidents caused by some error in the car, whether it be an ignition switch or a gas pedal or a piece of software, will the public tolerate from a company per year? How many? 0, a couple, we don't know, okay? But if we're traveling 1 trillion miles and the error rate needs to be that low, what are we going to do? And the answer is don't sleep the first night after you sign the contract. and that's the problem that both of us are wrestling with. The other way to look at it is how good are people at driving? Some of the numbers are incredibly sad. Around the world, 1.25 million deaths per year from car accidents. 1.25 million deaths, okay? Dozens of jumbo jets per day crashing. Incredibly bad. How bad is it in the US? 30,000 per year on the order. Okay, 30,000, order of magnitude, 300 days in a year, 100 people per day. On the news, we don't see any news about the 100 people that died every day in a car accident in the US. Terrible numbers. At the same time, you look out of a plane down at the ground, there's cars everywhere. We drive like crazy, 1 to 2 hours a day, like Ken said. Okay, how good are we at driving? Incredibly good. 1 fatality per 100 million miles of driving. So the per distance fatality rate means driving is actually quite safe. And that includes drunk driving, distracted driving, tired driving, all of those other things. 1 fatality per 100 million miles. Our cars that we come up with have to be much better than that for the public to trust that this machine can drive them safely. So this problem is quite hard, and the companies that are doing it, and Ford is certainly one of them, are very, very bold to do so.
A few minutes for questions from the floor. My goodness. Over here. Yeah, we need a mic. Here comes the mic.
Yes. What kind of passenger experience are you trying to achieve in these vehicles that you're going to build? Because it's still going to be, I assume, a consumer product. How do you want us to feel?
So let me address that first. We've thought a lot about this, which is why the announcement we made earlier this week addressed the pain point associated with mobility and freedom in environments where driving personal vehicles is challenging. We know there are millions of people every day that need to move in urban environments that are heavily congested, and the choices you have today are really pretty limited. I mean, it's a personal vehicle that you drive in a city during rush hour is not a good experience. You have to park it, it's expensive, the congestion is there, it's not convenient, and so a lot of people are voting for alternative modes. That's why Uber is being so successful. But the Uber business model is not scalable, and it's very expensive, and it's not accessible to the masses because it's much more expensive than personal vehicle ownership. It's about $6 a mile, and personal vehicle ownership is about $1 a mile. So the experience that we're seeking is, what if you had the ability to get where you wanted to go and you knew that you could get there safely in a vehicle that would deliver you there at a cost that was roughly the same as personal vehicle ownership, at $1 a mile or even less, because you don't have to pay a driver. The technology's been amortized across a much longer life, many more miles, because they can be in service, in a ride service, for much longer than for many more miles than you would ever drive a personal vehicle. So that's the target experience we're looking for initially, because we think that will solve a huge pain point, and it'll also make mobility for people who can't drive today, whether they're blind or don't have a driver's license, or they're aging like my father, or maybe you're young and you are giving new choices to families to avoid driving their kids around to soccer practice. So these options we think will be available once the technology is mature enough and you can introduce these into the right environments so that you can give people who live in these environments or work in these environments a great experience at a great cost point with much more safety than the stats that Gill just quoted. So that's our current thinking for the first deployment. And then later, as the cost comes down, people will see that these vehicles are actually interesting and they may want to buy them.
Let me add, and sorry to make these answers really long, but there's a technical reason that Ken's right also, that a number of us in the industry see here, that rideshare is a beautiful match for the kind of autonomy that we're talking about here. When you first deploy these systems, you can't deploy them everywhere. If the weather's bad, if the traffic's very bad, if your maps are not very good, there's a number of circumstances where the system won't work, okay? What's wonderful about rideshare is that if you're in those circumstances, you can send a car that has a human driver at a higher cost per mile. But if the circumstances are good, you can send the autonomous car without the human driver. So that's one of the reasons. The second is, unlike a personally owned vehicle, which sits in the garage or the driveway or the parking lot 90-some-odd% of the time, perhaps 98, 99% of the time, a rideshare vehicle can operate almost all the time. And so the economics dramatically shift, and the amount of cost that we can invest in the technology that will go in the car, that budget goes way up. And so it again becomes this kind of a sweet spot. So for those of you, and I know there's lots of you from the business world, that's why you're seeing this match between rideshare and autonomous driving.
I can't imagine hailing a cab in New York and seeing a ghost cab pull up with no driver. I mean, that's why they're changing the rules on taxi drivers. They don't have to know English anymore, I guess, because they're figuring they'd all be robots instead of actual people. Sir, behind you, Arthur. Yes.
Jean Smith, what are some of the bigger challenges? What are some of the bigger challenges to accomplishing your goal right now? It seems 5 years is a projection right now, but some of the obstacles that I hear casually are cars can't detect mothers with baby strollers or crossing guards. Maybe you could comment on that. Thank you.
So there are a lot of challenges, but I think one of the biggest challenges is understanding the environment around the vehicle with the kind of precision you need to make a decision around the path. And you cited one example where humans are really good at pattern matching. That's one of the things we are really good at. And we're good at that because our brain is the ultimate neural network. But what sometimes is missed when you think about the power of the brain is the fact that our brain and our eyes work together. Our eyes see optically, I mean, they're amazing optics. And our eyes can take in lots of information and feed it to our brain, but it doesn't feed everything to our brain. It filters some of the information and sends into the brain the things that the eyes, the retinas believes are important. And then our brains can then process that information in real time and help us make decisions. So one of the things we're trying to do, and we're working on, it's an area of active research, is to embed that kind of learning and capabilities into the software for the vehicle to process that information and make decisions smartly, accurately, like we would. Now, the advantage of the vehicle is, unlike people, the vehicle can have eyes in the back of its head. And so our sensors can look in all directions. And also, unlike people, our sensors can actually see out to 200, sometimes 300 meters. It can bounce off other buildings and look around corners. And so the vehicle has some advantages over people. And so the combination of really good sensors and really smart software that can process information, kind of like our brains do, is giving us the ability to solve some of these hard problems. But don't misunderstand me. That's a really hard problem. But we have literally hundreds of people working on that hard problem who are skilled in the science of machine learning and data and analytics and what we call reasoning. So, hard problem.
Sir, Philip?
I wanted to ask you about the muskox in the room. Could you comment on what your friends at Tesla are doing and how what you do compares and contrasts to that?
So we touched on this distinction between driver assist and fully autonomous. And Gill used the words chauffeur and guardian. That distinction is incredibly important. And first of all, let me give Tesla credit where they deserve it, which is they've done some amazing things. They've built a beautiful car, and they're doing some really great technology to assist the driver with what they call autopilot. And they've also done a really nice job of building an electrical architecture into their vehicle so it can be updated over the air. And they've done a really nice engineering job. But their approach to autonomy is what we call bottom-up, which is assisting the driver and having that assistance get better and better and better as the sensors learn and as it gets information about the environment. We think that approach can lead to an extremely good driver assist technology solution where the driver still needs to be able to re-engage when you get to what we call a corner case. A corner case is a case where your sensors haven't seen something yet, and so therefore you don't know what to do. And if you don't know what to do, you better have a human there to engage to safely get to where you want to go. And if you don't, as you get better and better autonomy, our research has shown that people will find other things to do, and they won't stay engaged. And so that's why a bottom-up approach, we think, is not the approach for delivering a fully autonomous vehicle where you don't need a driver.
So I would make a distinction just a little bit on that, which is maybe just to clarify what our position is. There are actually two issues that are buried in there. One is, do you do what in the industry we call level 2 or level 3, which is where you have it in chauffeur mode, but at some point when it gets to the corner case, it suddenly goes, bing, I can't handle this anymore, now it's your car. That's the taking turns approach, pilot, co-pilot thing. And Ken's exactly right that you have to worry about that handoff because often people will overtrust the system and say, I think it'll be able to handle everything. I'm going to go read my mail or send text messages to somebody or fall asleep. You know, lots of different things can go wrong. That's distinct from the question of whether we want to have a guardian where you drive all of the time, but the guardian is always watching over you and making sure that if you're about to do something that's going to get you into a corner case yourself and have an accident, it will take over temporarily, and there's no handoff issue there. You're trying to drive, but it grabs the wheel from you and says, no, 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 do this, and then it gives it back to you. That's the sort of thing that I was talking about, which is a little different.
That's right, but Tesla is not doing that, to my knowledge.
Over here? Sir.
Yeah,
I'm sorry, here comes the mic.
I'm Tyler Smith. To what extent does an autonomous car require a real-time connection to something external like the internet or GPS?
So I'll take it first and I'll flip it to Ken. And my guess is we're doing the same thing. We have a lot of efforts underway, and the industry as a whole is looking at something called DSRC, which is a way for cars to talk to infrastructure that in the future we imagine will be built into intersections. For instance, to let a car see around a corner to see what the traffic is there, and other forms of hookups to the internet where you can get traffic and things like that. It sounds great, but of course we need to be careful. And we need to be careful because what if suddenly that link is broken? And this was a lesson driven home to me, actually for both of us, by the kind of work we used to do in defense where an adversary might suddenly cut you off from the internet. How do you keep on going in a safe way? Our position is we think the cars have to be safe and be able to operate even if they're disconnected. And we have to be very careful that our cars are not spoofed by inaccurate data that might come from the internet.
The only thing I'll add to that is connectivity to the internet is important to us during the testing and development phase so that we can capture knowledge from what the vehicles see and the cases that are these corner cases where you don't know what to do, so we can then learn how to do the right thing. So we have our cars connected to help us capture the data to do validation and testing. But once we deliver a vehicle that's fully autonomous, it's got the smarts in the vehicle already. So it does not require connection to the internet because we don't think it's reliable enough.
Over here. Ma'am?
Hi, Marion Conway. My husband has only driven Ford F-150s. And so my question is, what are your thoughts about ratcheting up to something like big brown UPS delivery trucks being fully autonomous?
Boy, that's a great question. Thank you for that. Because, you know, as you think about the promise of autonomy that is fully autonomous and all the things that it could be applied to make our lives better, delivery of packages is certainly one of them. And so we've been thinking a lot about that, how you would put an autonomous capability into, say, a delivery vehicle or an F-150. Imagine how it might be used for doing some of the more mundane tasks where you don't need a driver to move from one point to another. We see a lot of potential promise of that in terms of services and in environments where you could map the environment so you could do full autonomy and then enable new ways to move. Also, we're thinking about things like dynamic shuttle, where you would offer a service to have multiple people go into a van, and then that van could move those people where they want to go, and it could be done autonomously so that the cost per mile and the service could be very high quality. So a lot of opportunities there in the commercial space for moving people and for moving packages.
You need one of Gill's robots to unload the packages in the back if you've got a driverless UPS van.
Well, you know, it's interesting. Amazon is doing some research around robotics and drones and how drones might marry with an autonomous vehicle. And so the possibilities are endless, because once you have the ability to autonomously move a vehicle safely from one point to another in an environment that you think is, that you know is safe because you've got a really detailed map of that environment, you know, the possibilities for making our lives better, moving people who can't drive, moving packages to your doorstep safely, smartly at a cost point that is disruptive. I mean, I think it's pretty exciting.
In the back, ma'am?
Yes, can one of you comment on the recent Tesla death that was, I think, in LA, that from the driver that ran into a truck?
Well, I mean, I'm not going to comment on Tesla, but I think.
Maybe I should clarify how it might impact your thinking because of consumer confidence.
Yeah, it's validated that it's validated for us the importance of taking more of a top-down approach, where we are responsible for evaluating all of the corner cases and understanding the environment, and having a detailed map of the environment married with a full suite of sensors and a fully capable software set that's integrated into a vehicle that's got redundancy. That's the approach we're taking for giving our customers the confidence that we can allow autonomous driving in an environment where you don't need a driver, because this re-engagement issue is a real problem. And you know, it's really unfortunate that setback happened, and you know, our hearts go out to the family, of course. And it's our commitment, because we've been delivering safe vehicles for over a century, and it's our commitment that when we put an autonomous vehicle on the road, that it's going to have the same credibility and safety and backing of Ford Motor Company that all of our vehicles do.
Unfortunately, we're out of time right now. Let's get your vote machines out and cast your vote. How do we do?
Okay.
Not that
Well,
much
we
of a
got an
change. I'm
improvement, a little
surprised.
And Alex, could I comment on, you know, we were talking before the session, and my comment before the session was, it's a great question, but it's probably not the right question to ask. And the right question to ask to me is, would you ride in an autonomous car when it becomes available?
Thank you to our panelists.